A strip of coral and jungle rises from the ocean, humid and still beneath a hard white sky. The island is small, defended, ringed with bunkers carved into sand and volcanic rock. Japanese infantrymen watch the horizon through field glasses. They see landing craft. They expect rifles, mortar, naval gunfire. They do not expect bulldozers. When the first American tractors grind onto the beach behind the assault waves, some defenders reportedly laugh. The terrain is swamp and tangled growth, coconut palms. Roots like iron chains, the ground churns under rain. No airstrip could exist here, they believe, not quickly, not under fire. But by nightfall, steel planking is already being unloaded. By the second day, trees are falling in straight lines. By the third, the jungle floor is being flattened into geometry. Within a week, aircraft engines will echo where birds once nested. Across the Pacific, on island after island, this pattern will repeat, and with it, the balance of the war will begin to shift. After the attack on Pearl Harbor, Japanese forces advanced with astonishing speed. The Philippines fell, Malaya collapsed. Singapore surrendered in February 1942. Guam, Wake Island, and vast stretches of the Dutch East Indies were seized. By mid-1942, Imperial Japan controlled a defensive perimeter that stretched thousands of miles from the Aleutians in the north, through the Central Pacific, down to New Guinea and the Solomons. It was an empire built on distance. The Pacific Ocean covers more than 60 million square miles. Between each speck of land lay hundreds, sometimes thousands of miles of open water. Any enemy attempting to retake these islands would face vast logistical strain. Fuel, food, ammunition, spare parts. Everything had to cross ocean expanses vulnerable to submarines and aircraft. Japan's strategy relied on this reality. Rather than matching American industrial production ship for ship, Tokyo sought to create a fortified barrier. Each island would be transformed into a strong point, airfields dug into coral, artillery concealed in caves, infantry entrenched in mutually supporting positions. The expectation was simple. Terrain was the silent ally. Many of these islands were not gentle beaches ready for development. They were volcanic ridges, razor-sharp coral reefs, dense mangrove swamps, and suffocating jungles. Rain fell in torrents, heat rotted equipment. Mosquitoes spread disease, roads rarely existed. Ports were shallow or non-existent. Japanese officers believed such environments inherently resisted rapid transformation. Even where the Japanese had constructed airstrips, those fields often required months of labor from local workers and military engineers. Coral had to be crushed, jungle cleared by hand. Equipment shipped from distant bases. Construction was slow, exposed, and vulnerable to air attack. Veteran aviators were lost. The initiative began to tilt. 2 months later, in August 1942, U.S. Marines landed on Guadalcanal in the Solomon Islands. There, they captured a partially constructed Japanese airfield, soon renamed Henderson Field. That strip of dirt became a hinge of the war. Aircraft operating from it threatened Japanese supply lines and forced nightly naval clashes in surrounding waters. Guadalcanal demonstrated something critical. Air power determined who controlled the sea lanes, and air power depended on runways. Without a nearby airfield, naval forces operated blind and exposed. With one, even a small garrison could project influence far beyond its coastline. By early 1943, American planners understood that retaking the Pacific would not mean simply defeating island garrisons. Yet at this stage of the war, the scale of that ambition was not fully visible. The Carolines and the Marianas would buy time. They fortified beaches, dug tunnels, stockpiled ammunition. But they underestimated something fundamental. The United States was not merely deploying soldiers. It was mobilizing an industrial civilization. Shipyards in California and Virginia were launching vessels at unprecedented rates. Aircraft factories in Detroit and Seattle were producing bombers and fighters in numbers the Axis could not match. And behind the combat divisions stood a new kind of battalion, trained not only to fight, but to build. What Japanese defenders would soon confront was not simply invasion. It was transformation at mechanical speed. To understand how that transformation became possible, we must look at the machinery and the men behind it. In early 1942, after the shock of Pearl Harbor and the rapid Japanese advance, the United States Navy recognized a structural weakness. Combat forces could seize territory, but who would build it into something usable under fire in hostile climates and at speed? They became known as the Seabees. Drawn largely from civilian construction trades, carpenters, steelworkers, electricians, heavy equipment operators, these men were not ordinary recruits. Many were older than standard enlistees. They brought professional expertise into uniform. Unlike civilian contractors, they were trained to fight. If attacked, they would defend their work sites with rifles in one hand and engineering tools in the other. In the Pacific, Army engineers would build roads through jungles, bridges across ravines, fuel depots, ports, and airfields capable of sustaining large-scale operations. But manpower alone was not the decisive factor. The decisive factor was industrial preparation. American planners understood that Pacific Islands lacked infrastructure, so they manufactured it in advance: prefabricated huts, portable sawmills, modular fuel systems, water purification plants, mobile hospitals. Entire base components were designed to be unloaded from ships and assembled rapidly on hostile shores. Most transformative of all was the development and mass production of pierced steel planking, commonly known as Marston mat. These interlocking steel sheets could be laid directly over leveled earth or coral, creating a stable runway surface in days rather than months. The perforations allowed water to drain. The steel resisted tropical decay. If damaged by bombing, sections could be replaced quickly. It was engineering tailored for expeditionary war. At Guadalcanal, engineers learned under fire. Henderson Field had to be repaired constantly. Japanese naval bombardments cratered its surface. Rain turned soil to mud. Supplies were scarce. Yet within weeks, the airstrip was operational enough to host fighters and bombers that contested the skies over the Solomon Islands. The lesson was clear: speed mattered more than perfection. An airfield did not need to resemble a permanent base. It needed to function immediately. Even a rough strip allowed fighters to refuel and rearm closer to the front. Medium bombers could strike shipping lanes. Reconnaissance aircraft could extend the fleet's vision. By late 1943, this doctrine matured into a system. The Central Pacific Drive under Admiral Chester W. Nimitz targeted island groups step by step: the Gilberts, the Marshalls, the Marianas. Simultaneously, General Douglas MacArthur advanced along New Guinea toward the Philippines. Both strategies depended on leapfrogging, bypassing heavily fortified positions and seizing islands, suitable for rapid development into air bases. An island's value was measured less by its beaches and more by its potential runway length. Engineers began landing within hours of assault waves. Sometimes they worked while artillery still fired inland. Bulldozers cleared debris beside smoldering bunkers. Steel matting rolled out behind advancing tractors. The timeline compressed. In some operations, aircraft were landing within 72 hours of initial assault. For Japanese planners, this acceleration undermined the very premise of their defensive perimeter. They had assumed captured islands would remain unusable for extended periods, buying time to counterattack or reinforce adjacent sectors. Instead, each lost island risked becoming an Allied air platform almost immediately. Airfields multiplied across the Pacific like stepping stones. Each one shortened the distance to the next objective. Each one extended fighter cover over amphibious fleets. Each one allowed heavier bombers to operate deeper into Japanese-held territory. The Pacific Ocean did not shrink physically, but operationally it began to contract. And as these improvised runways expanded into strategic hubs, particularly in the Central Pacific, their impact would no longer be measured in tactical advantage alone, but in the shifting balance of the entire war. From here, the story unfolds not from a single perspective, but through several angles: human, tactical, technological, and strategic, each revealing how engineering reshaped the battlefield. They did not arrive with dramatic speeches. They arrived with survey stakes, measuring tapes, and diesel engines. Sometimes earlier if terrain assessment was urgent. On islands such as Tarawa in November 1943, engineers came ashore while pockets of resistance still held inland. Sniper fire cracked through palm trees. Artillery echoed from concealed positions, yet bulldozers began moving almost immediately. The work was brutal. Coral dust cut lungs and eyes. Heat exceeded 100 degrees Fahrenheit. Rain transformed cleared areas into mud fields. Machinery broke under constant strain. Spare parts were limited. Many Seabees were in their 30s or 40s, older than the infantry beside them. They had left civilian construction firms in New York, Chicago, Los Angeles. Now they slept in foxholes beside half-assembled fuel tanks. Casualties occurred not only from enemy fire, but from exhaustion and accident. Runway grading required long shifts, often 20 hours at a stretch. Floodlights illuminated night work, making crews visible targets. Yet construction rarely stopped. Their objective was simple: make the island operational before the enemy could react. There were no dramatic charges. No cinematic duels, but when the first aircraft landed safely on a strip carved days earlier from jungle or coral, the transformation felt tangible. The engineers had turned geography into advantage. And in the Pacific, geography was everything. The tactical angle, airfields as multipliers. In amphibious warfare, distance dictates vulnerability. Carriers were powerful but finite. They required protection. They needed to refuel and rearm. And their loss could shift a campaign overnight, as demonstrated at the Battle of Midway. Land-based airfields changed that equation. Once operational, even a modest strip could host fighters that extended protective range over transport convoys. Bombers could strike neighboring islands before reinforcements arrived. Reconnaissance planes could monitor Japanese naval movements. The result was compression of operational space. Consider the Central Pacific Campaign of 1943–1944. After the seizure of the Gilbert Islands, engineers rapidly expanded airstrips that supported operations into the Marshalls. Once fields were operational in the Marshalls, aircraft could escort assaults toward the Marianas. Each new runway created overlapping circles of air coverage. Japanese garrisons that expected months of isolation suddenly faced sustained bombing within days. Supply barges were attacked, reinforcements intercepted, command structures disrupted. The defensive perimeter was not shattered in a single blow. It was eroded by runways. Every completed airfield forced Japanese commanders to rethink supply routes, reposition aircraft, and disperse assets. The technological angle, steel against jungle, none of this acceleration would have been possible without machinery. Bulldozers, graders, cranes, portable rock crushers, these were not improvised tools. They were mass-produced in American factories and shipped across oceans specifically for expeditionary warfare. But one innovation stands apart: pierced steel planking, known formally as PSP and informally as Marston mat. These interlocking steel sheets could be transported in stacks and laid rapidly across prepared ground. The perforations reduced weight and improved drainage. Sections locked together with relative ease, allowing crews to extend runways almost like assembling a mechanical puzzle. On coral islands such as Kwailine Atoll, engineers blasted and crushed coral into a compacted base. Steel planking followed. Within days, fighter aircraft were landing. The technology was simple in concept. Factories in the United States produced thousands of tons of PSP. Cargo ships delivered it in steady streams. What had once required months of curing and grading could now be achieved at remarkable speed. Even heavy bombers benefited. Longer runways were built with layered coral foundations topped with steel or compacted surfaces. Drainage systems were installed to counter tropical rain. Fuel storage tanks were buried or sandbagged against attack. This was not improvisation. It was systemic preparation. The jungle resisted. Roots tangled bulldozer blades. Monsoon rains carved gullies overnight. Heat warped equipment. Yet machinery returned each morning, engines coughing to life before sunrise. Steel gradually replaced foliage. The transformation was not elegant. It was loud, abrasive, mechanical. And it was relentless. Across the Pacific, Japanese defenders observed this pattern with increasing concern. The laughter that sometimes greeted early landings faded as aircraft began appearing overhead sooner than expected. But beyond the machinery and tactical calculations lay deeper forces, leadership decisions. Engineering in the Pacific was not accidental. It was directed. Admiral Chester W. Nimitz understood that naval victories alone would not retake an ocean. Fleets could win battles, but fleets required forward bases. Without land-based air cover, each operation risked overextension. Simultaneously, General Douglas MacArthur advanced along the northern coast of New Guinea with a complementary approach. His strategy emphasized bypassing heavily fortified Japanese positions, isolating them rather than assaulting every stronghold directly. But isolation only worked if airfields could be constructed quickly on newly seized ground. Both commanders depended on engineers as strategic enablers. Planning documents increasingly listed runway length and soil composition alongside troop strength and artillery counts. Intelligence units analyzed coral density. Survey teams studied tidal patterns. Before Marines stormed beaches, engineers were already calculating gradients. The speed of construction became part of operational timing. Assault timetables assumed that within days of securing a beachhead, aircraft would operate from it. This assumption reshaped campaign sequencing. Leadership recognized something critical. In the Pacific, logistics was offense. An airfield was not merely support infrastructure. It was a weapon. By 1944, this doctrine was fully integrated into the Central Pacific Drive. Each target was chosen not solely for its defensive weakness, but for its aviation potential. Islands unsuitable for rapid development were sometimes bypassed entirely. Strategic geography had been redefined by engineering capability. The enemy angle, the shrinking perimeter. Japanese defensive planning had relied heavily on delay. The concept of a fortified outer perimeter assumed that each island would impose high costs and extended timelines on an advancing enemy. Reinforcements could be shifted along interior lines. Naval counterattacks could disrupt vulnerable staging areas. But when American engineers reduced construction time from months to days, the temporal buffer collapsed. After the Gilbert Islands campaign in late 1943, Japanese commanders observed that newly captured positions were operational far sooner than anticipated. Aircraft appeared overhead with unsettling speed. The seizure of Kwajalein Atoll in early 1944 reinforced this reality. Within a short period, American aircraft were using the atoll as a forward base for deeper strikes. Supply routes between the Marshalls and the Marianas became increasingly exposed. Fuel shortages compounded the problem. Replacement pilots lacked the training of earlier cohorts. More troubling was the psychological dimension. Garrisons stationed on isolated islands began to understand that capture no longer meant temporary setback for the enemy. It meant immediate transformation of their former defensive ground into an Allied launch point. An island lost today could host bombers tomorrow. The perimeter did not fall in one catastrophic moment. It contracted, step by step, runway by runway. The moral and psychological angle. Laughter fades in the early months of the Pacific War. Confidence favored Japan. Victories had come swiftly. American forces were perceived as reactive, distant, unprepared for tropical warfare. But engineering altered perception. When bulldozers rolled ashore under fire, it signaled something different from a standard assault. It signaled permanence. Infantry can withdraw, fleets can redeploy. But steel laid into the earth declares intention. American engineers worked openly, visibly. Smoke from burned vegetation rose in columns. Machinery roared through humid air. Survey stakes marked straight lines across previously irregular terrain. What had been jungle became grid. For Japanese defenders observing from concealed positions, the message was unmistakable. The Americans were not merely seizing ground. They were reshaping it. This realization carried weight. The psychological advantage of difficult terrain diminished. Jungle had once implied delay. Now it implied only labor. Coral reefs that once protected lagoons became raw material for runways. On islands bypassed rather than assaulted, garrisons faced isolation. Aircraft from newly built fields cut supply lines. Communications faltered. Resupply attempts were intercepted. The laughter reported during early landings, the belief that hostile terrain would stall development, gave way to a quieter understanding. Industrial capacity had entered the battlefield in physical form, and as 1944 progressed, this convergence of leadership doctrine, technological innovation, and psychological erosion would reach its most decisive expression in the Marianas. where the distance to Japan itself would finally fall within range of sustained air attack. From that moment forward, the war would no longer be defined solely by contested islands, but by what could rise from them. June 15, 1944, U.S. forces land on Saipan. The island is heavily defended. Nearly 30,000 Japanese troops are entrenched across ridges and caves. Artillery is zeroed on the beaches. The fighting will last weeks. It will be costly. But even before the island is fully secured, survey teams begin their work. Saipan is not just another stepping stone. It lies approximately 1,300 miles from the Japanese home islands. That distance matters. It places Tokyo within range of a new aircraft entering service in 1944, the B-29 Superfortress. The B-29 is large, complex, and demanding. It requires long, durable runways. It consumes vast quantities of fuel. It needs maintenance facilities, bomb storage depots, radar installations, and defensive perimeters. Saipan's value is not symbolic. It is geometric. Fighting continues into July. Japanese resistance is fierce, culminating in massed banzai attacks and the collapse of organized defense. By July 9, 1944, Saipan is declared secured. Casualties on both sides are heavy. The civilian toll is devastating. Almost immediately, large-scale construction begins. Seabees and Army engineers expand and build airfields across the island's relatively level plains. Existing strips are lengthened, new ones are carved out, coral is blasted and compacted. Heavy machinery operates in shifts. The scale dwarfs earlier island projects. This is no temporary fighter strip. It is a strategic air complex. Within weeks, aircraft begin arriving. By November 1944, B-29 bombers operating from Saipan launch raids against industrial targets in Japan. The psychological barrier that once shielded the home islands is broken. But Saipan is only part of the turning point. July 24, 1944, American forces land on Tinian. The island is smaller, but its terrain offers vast flat expanses, ideal for runway construction. Japanese defenses are concentrated elsewhere on the beaches, allowing U.S. forces to secure lodgements more rapidly than expected. Again, construction begins almost immediately. What follows is one of the most ambitious. Northfield on Tinian expands into a massive B-29 base complex. 4 parallel runways, each thousands of feet long, are constructed. Taxiways interconnect them. Hard stands and maintenance areas multiply. Fuel storage facilities are installed at scale. By early 1945, Tinian becomes one of the largest airbases in the world. The speed of transformation is staggering. Within months, what had been contested tropical ground becomes a primary launch point for strategic. Japanese planners had never envisioned such rapid conversion of captured territory into heavy bomber platforms aimed directly at the homeland. Defensive perimeter strategy assumed that even if outer islands fell, Japan itself would remain insulated by distance. That insulation dissolves in the Marianas. From Saipan and Tinian, B-29 formations now possess the range to strike Tokyo, Nagoya, Osaka, and Kobe. Early missions faced technical difficulties and high-altitude jet stream challenges. Results are mixed at first. But the platform exists. Airfields carved from jungle and coral have redefined the war's geography. The Marianas campaign also triggers political shockwaves in Tokyo. The loss of Saipan leads to the resignation of Prime Minister Hideki Tojo in July 1944. The strategic implications are undeniable. What began as bulldozers landing behind assault waves has culminated in direct pressure on the Japanese mainland. And yet, even this was not the final transformation. Because once the infrastructure was in place, once the runways stretched across Tinian's northern plateau, the tempo of air operations would intensify dramatically, reshaping not only the battlefield but the course of the war itself. By late 1944, the Marianas were no longer contested objectives. They were operational platforms. From airfields on Saipan, Tinian, and nearby Guam, the United States Army Air Forces assembled the 21 Bomber Command under Major General Haywood S. Hansel, later replaced by Curtis LeMay. Their aircraft, the B-29 Superfortress, the B-29 was the most advanced bomber of the war, pressurized cabins. A range exceeding 3,000 miles. But its complexity demanded infrastructure, long runways, vast maintenance depots, spare engines, fuel reserves measured in millions of gallons. The engineers had delivered that foundation. The first B-29 raids against Japan from the Marianas began in November 9. Early missions targeted aircraft factories and industrial centers. High-altitude precision bombing proved difficult. Japan scattered formations and reduced accuracy. Mechanical failures plagued the new bombers. Yet sorties increased. In 1945, command shifted to Major General Curtis LeMay. High-altitude daylight bombing gave way to low-altitude nighttime incendiary raids designed to exploit the vulnerability of Japanese urban construction, much of it wood and paper. On the night of March 9 to 10, 1945, hundreds of B-29s departed the runways of the Marianas. Their destination, Tokyo. The raid that followed, often called Operation Meeting House, became one of the most destructive air attacks in history. Incendiary bombs ignited massive firestorms across densely populated districts. Tens of thousands were killed in a single night. Vast areas were reduced to ash. The bombers returned not to distant carriers or fragile expeditionary strips, but to massive, purpose-built airfields carved months earlier from coral and jungle. Crews landed, refueled, rearmed, and prepared to fly again. Night after night, waves of aircraft struck Nagoya, Osaka, Kobe, Yokohama. Transportation networks strained. Civil defense systems overwhelmed. Japanese fighter response weakened. Fuel shortages, limited training, and interception capability came under increasing attack. The defensive perimeter that once relied on distance now confronted sustained strategic assault. And still, the runways expanded. On Tinian North Field grew into a grid of immense scale, 4 parallel runways stretching across the northern plateau. Thousands of ground personnel operated in coordinated shifts. Bomb dumps extended into cleared jungle. Maintenance crews labored around the clock to keep aircraft airworthy. In 1945, the Marianas were launching hundreds of sorties per week. On August 6, 1945, a single B-29 named Enola Gay departed from Tinian's North Field, its target, Hiroshima. 3 days later, another B-29, Boxcar, lifted from the same island toward Nagasaki. The atomic bombings marked a final and devastating escalation. Regardless of ongoing debate over causation and surrender dynamics, one logistical reality is clear. Without the rapid seizure and construction of Marianas airfields in 1944, those missions would not have been feasible from land bases within range. What began with bulldozers on contested beaches culminated in aircraft capable of reshaping global history. The Japanese High Command had anticipated invasion fleets. They had fortified shorelines. They had prepared for attritional island defense. They had not fully accounted for the speed at which lost terrain would become strategic launch pads. The Pacific Ocean, once a shield, had become a network of interconnected air corridors. The jungle islands that defenders believed would slow any advance instead accelerated it. Engineering had altered time itself within the campaign, compressing months into days, shrinking distances that once defined strategy. By the summer of 1945, the decisive shift was no longer theoretical. It was visible in smoke rising over Japanese cities and in the relentless cadence of engines, lifting from runways that had not existed a year before. And with Japan's surrender in September 1945, the consequences of those rapidly built airfields would extend far beyond the Pacific battlefield. When Japan announced its surrender on August 15, 1945, the Pacific War ended not with a single decisive island assault, but with accumulated pressure. Much of that pressure originated from airfields that had not existed in 1942. Between 1942 and 1945, U.S. naval construction battalions and Army engineers built, repaired, or expanded hundreds of airstrips across the Pacific theater. From the Solomons to the Marianas, from New Guinea to Okinawa, runways multiplied across once remote terrain. On Tinian alone, Northfield grew into one of the largest air bases in the world, supporting massive B-29 operations. On Saipan and Guam, similar complexes sustained strategic bombing campaigns through 1945. By mid-1945, the 21 Bomber Command was launching hundreds of sorties per week. Japanese industrial production, already strained by resource shortages and naval blockade, deteriorated under persistent air attack. Transportation networks were disrupted. Urban infrastructure suffered catastrophic damage. The cumulative effect was measurable. Oil storage facilities burned. Aircraft factories lost output capacity, shipyards slowed, railway yards became targets. The tempo of air operations increased even as Japan's ability to respond diminished. Yet the human cost was profound. Engineers who built these airfields endured combat casualties, disease, and exhaustion. Construction units worked in extreme climates, monsoon rains in New Guinea, searing heat in the Marianas, typhoons that tore through half-completed installations. Machinery accidents claimed lives. Sniper fire and artillery occasionally struck work crews even after major resistance had collapsed. They were rarely the focus of headlines, but their contribution shaped the battlefield. By war's end, the Pacific Ocean was no longer an unbroken defensive moat for Japan. It had become a network of Allied air corridors, each anchored by runways constructed under pressure. Strategically, the shift forced Japan into reactive defense. Rather than projecting power outward as in 1941-1942, the Imperial Japanese military struggled to protect its own homeland. Air defense resources were stretched thin. Pilot training programs shortened under fuel constraints. Aircraft production faced constant disruption. The defensive perimeter strategy, designed to trade space for time, ultimately failed because time compressed. Islands, once assumed to delay an enemy for months, were operational within days. The loss of one base did not simply reduce territorial control. It created a forward platform for the adversary. The Pacific Campaign demonstrated that territory could change function almost immediately. This realization influenced post-war military doctrine, and rapid runway construction became standard considerations in strategic planning. The concept that logistics could determine tempo, and tempo could determine victory, was reinforced at institutional levels. But the aftermath was not limited to doctrine and numbers. The cities struck by aircraft from Marianas airfields bore scars that endured for generations. Urban districts flattened by incendiary bombing faced massive reconstruction challenges. Civilian casualties reshaped political discourse within Japan. The war had been industrial from the beginning. By its end, industrial capability, expressed through engineering and air power, had become decisive. Yet even as surrender documents were signed aboard the USS Missouri in Tokyo Bay, military planners worldwide studied the Pacific campaigns for deeper lessons. Because the airfields built across jungle islands were not only instruments of immediate victory, they were signals of how future wars might be fought. After 1945, military strategists studied the Pacific War not only as a victory, but as a transformation of warfare itself. The Pacific Campaign demonstrated that modern war was no longer decided solely by naval gunfire or infantry assaults. Instead, it was determined by industrial capacity, engineering speed, and supply chain resilience. The United States emerged from the war with vast experience in expeditionary base construction. The techniques refined across the Pacific would later influence Cold War strategy. Forward air bases, rapid runway deployment units, and mobile engineering battalions became standard military assets. The Seabees and Army engineers had proven that infrastructure could be weaponized. The ability to build airstrips under combat conditions gave Allied forces operational flexibility. It allowed aircraft to operate closer to enemy territory. It reduced fuel consumption for long-range missions. It expanded surveillance capabilities across vast ocean spaces. Other nations took note. Post-war Soviet and European military doctrine incorporated similar logistical thinking. Air power was no longer purely about aircraft design or pilot skill. It was about where aircraft could operate from, and how quickly those locations could be prepared. The Pacific War also reshaped civilian engineering practices. Rapid construction techniques developed for military use later influenced disaster response infrastructure and large-scale civil projects. Prefabricated structures, modular systems, and heavy earth-moving equipment became standard tools of post-war development. But perhaps the most important lesson was psychological. The war showed that psychological warfare could be indirect. Instead of targeting morale through propaganda alone, sustained logistical pressure could erode enemy confidence. Japanese defenders on isolated islands often fought long after strategic defeat became inevitable, because communication with Central Command had broken down. Isolation was as powerful as direct destruction. Historically, Japan's surrender was influenced by multiple factors, including the atomic bombings of Hiroshima and Nagasaki, Soviet entry into the war against Japan, naval blockade, and sustained bombing campaigns. The airfields of the Marianas were the launch platforms that enabled continuous strategic pressure. The Pacific Theater became one of the earliest examples of modern global reach warfare. Distance was no longer a protective barrier. Technology allowed power projection across oceans. Engineering shortened operational timeframes. Warfare became faster, more industrial, and more interconnected. Veterans who served in engineering units often reflected that they were fighting a different kind of battle, not always visible. Not always celebrated, but essential. Many returned home quietly. Their achievements were measured in numbers rather than medals, in miles of runway, gallons of fuel stored, tons of coral moved, and aircraft launched successfully into combat. Historians later argued that these engineering achievements were as important as any naval victory in determining the war's outcome, because wars are not only fought where bullets fly, they are fought where supplies move, where machines are repaired, and where land itself is reshaped to serve strategy. The Pacific War closed with a new understanding of power, not only firepower, but the power to move, build, and sustain war at global scale. And across the Pacific Islands, now quiet again under tropical winds, the runways remained. Some were eventually reclaimed by jungle, others became civilian airports. A few remain silent monuments to the moment when steel, machinery, and human endurance reshaped one of the largest theaters of war in history. From jungle clearing to global strategic dominance, the story of these airfields stands as proof that sometimes the fastest victories are not won by destruction, but by construction. The Pacific War was often remembered for its naval battles and dramatic aerial combat. But beneath the explosions and headlines was a quieter revolution. Engineering became strategy. Logistics became offense. Time itself became a weapon. The United States did not simply defeat Japan through superior numbers or firepower alone. Victory came through the ability to move faster, build faster, and sustain operations across vast distances. The jungle islands that once seemed to protect Japan's defensive perimeter became platforms from which attacks could be launched directly toward the homeland. The war changed how nations understood geography. Before 1942, oceans were barriers. After 1945, they were operational spaces. Aircraft, ships, and supply chains could connect continents in ways previously unimaginable. The men who built these airfields rarely received the same recognition as combat pilots or naval commanders. Yet their work made strategic bombing possible. Their labor turned captured land into launch points for decisive operations. History often remembers the explosions, but sometimes the most powerful moment in war is not when something is destroyed, but when something new is built in its place. The runways of the Pacific stand as reminders of that truth. They represent a war won not only through courage and firepower, but through patience, machinery, and human endurance against environment and enemy alike. And in that sense, the Pacific War was not only a conflict of nations. It was a conflict of systems, of industry, engineering, and time itself.